This is a short video that illustrates two properties commonly used in geometric proofs, the transitive and substitution properties. These are also properties that are commonly confused, so I'm going to try to kind of give you a way to distinguish between when we use one property over the other. Let's look at an illustration of the transitive property that you should be familiar with. What conclusion can you make from the following? If NASA launched some cows into space, then they would be put into low Earth orbit. If some cows were put into low Earth orbit, then they would be the herd shot round the world. Okay, so this is bringing back that chain of reasoning that we talked about when we looked at conditional statements. Okay, so you can see the if P then Q and if Q then R scenario here. And we remember from the chain of reasoning that if P implies Q and Q implies R, then P must imply R, assuming that the initial statement was true. So, that being said, if NASA launched some cows into space, then they would be the herd shot round the world. Well, this type of chain of reasoning applies when we're talking about congruent segments and angles, or the measures of segments and angles being congruent as well. And we call it the transitive property. So the transitive property states that, an illustration, an example here, if angle Z is congruent to angle O, and if angle O is congruent to angle E, then we can conclude that angle Z is congruent to angle E. So you see this transitive, the transitive property kind of implies it's going across. That's the way I like to think of it. So you can see this Z, then O, O, then E, therefore Z, then E. So the theorem formally states that if angles or segments are congruent to the same angle or segment, then they are congruent to each other. And we can simply just state that as the transitive property. And then just an extension of that theorem is that if angles or segments are congruent to congruent angles or segments, then they're congruent to each other. So this would be a situation if we had four angles or four segments, and we knew that pairs of them were congruent, then we can conclude that they are all congruent. Let's look at a sample proof that involves the use of the transitive property. So we're given segments FG and KJ are congruent, and we're also given that segment GH and KJ are congruent, and we're asked to prove that KG is a bisector to segment FH. Okay, and just in the given statement here, you can see a possible use of the transitive property. So we see that repeated segment KJ. So we can, right from those given statements, make the conclusion that FG and GH must be congruent. So let's see what this proof looks like. All right, so we start with those two given statements. And like I said, we can conclude from those given statements by the transitive property that segments FG and GH are congruent. And if you take a look at the diagram, if FG and GH are congruent, okay, so that means that G is dividing segment FH into two congruent segments, and that's the definition of a bisector. So we can conclude that line KG bisects FH, because if a line divides a segment into two congruent segments, then it bisects the segment. Okay, so that's the transitive property. And again, notice that the transitive property involves congruence, or measures that are equal, and it involves at least three different measures or three different segments that are congruent. Substitution property is not something that's new to you. We've used substitution when we solve a system of equations, or you've used it even way back in pre-algebra when you were given the value of a variable and asked to replace the variable with the number. So substitution is used anytime where we need to replace something. We're going to replace a quantity, or replace an angle or a segment with something that's equivalent to it or congruent to it. So as an example, if we know angle 1 is complementary to angle 2, and we also know that angle 2 is congruent to angle 3, then we can substitute angles 2 and 3 for each other. So we can conclude that angle 1 is complementary to angle 3 by substitution. So you see we've replaced angle 2 with angle 3 just by substituting. So let's take a look at a proof that uses substitution. We are given that the measure of angle GEF is 90 degrees. We're also given that angle 1 is congruent to angle 3. So we want to prove that the measure of angle 2 plus the measure of angle 3 is 90 degrees. Okay, so if we plan this out, if we know that the measure of angle GEF is 90, and we can see that GEF is made up of angles 1 and 2, that means if we add angles 1 and 2 together, we're going to get 90 degrees. Okay, we also know that angles 1 and 3 are congruent, so we can do a substitution there, really. Anytime we see 1, we can replace it with 3. So let's see what this proof looks like. Okay, we start out with the given information that the measure of angle GEF is 90 degrees, and also that 1 and 3 are congruent angles. If 1 and 3 are congruent angles, that means we can conclude that their measures are equal, and that's by definition of congruent angles. Now notice, we need to make that conclusion because we're going to be dealing with measures in future statements here. Okay, we can never say, we can never just say angle 1 plus the measure of something else. Okay, we don't want to confuse congruence with equality here. And then in our next statement, this is what we said before, measure of angle 1 plus the measure of angle 2 is equal to the measure of angle GEF. That's by the angle addition postulate, or simply just addition is fine. And now in statement 5, we're doing two replacements, actually. We're using the substitution property twice. You see that we've substituted the measure of angle 3 for the measure of angle 1, because those two measures are congruent. And you could also see we substituted the measure 90 degrees for the measure of angle GEF. So we've made two replacements there. So we've used the substitution property. And we've proven what we were asked to prove. And that's it. I told you it was a short video. I will see you in class.